Hello and welcome. This is the final video from C5 Quantitative Analysis, and it's on testing ions using precipitate reactions. There is a really clear link in this video to the C4 topic, which is water testing, right at the very end of that topic. The aim of the specific aim of this video is that you should be able to describe the stages involved in the preparation of an insoluble solid. You should be able to use state symbols to provide a little bit more information about what's going on in reaction, and you should be able to use the idea of spectator ions and construct ionic equations for tests involving halides and sulfates. So that's the same test that we're in C4. Firstly, we have three familiar images, or they should be familiar. What we have here are the precipitates that are formed when you test using silver nitrate for the different halide ions. From left to right we have a chloride ion, a bromide ion and an iodide ion. All of these are tested for, and they're all making precipitates. The different precipitates made are silver chloride, silver bromide and silver iodide. That's why these precipitates have a different colour, because they're a slightly different compound. Alright, in general, a precipitation reaction happens when an insoluble solid is formed. You go from two aqueous solutions to an aqueous solution and a solid. And it's this solid here that is the precipitate in the reaction. For example, in this reaction that you can see just here, you've got lead nitrate and potassium iodide that react together to form the insoluble lead iodide, which is a bright yellow precipitate. When ions in solution react, because the ions are fully dispersed through the liquid, the collision frequency is really high, so precipitation reactions happen really fast, almost immediately. Precipitates form when the new ions are combined and it's making the insoluble compound there. Essentially all that happens is that the metal ions swap places, so lead nitrate and potassium iodide become potassium nitrate and lead iodide. And if you get a question like this in the exam, that's a fairly safe bet. If you're not sure what to do in a word equation, just swap the places of the names of the metals and you might well pick up a mark for a word equation. This is extended when we use symbol equations. So this is using the state symbols. Main state symbols, the four main state symbols are S for solid, AQ for aqueous, there are also L for liquid and G for gas. Liquid is the one that you probably come across the least often, because they tend to be oils and things like that, and water that's a liquid. Most often things that you think are liquids are generally aqueous solutions. So here what we have is lead nitrate reacting with potassium iodide. The lead and the potassium have swapped places. A little bit of balancing to do, but essentially the key thing that we're looking for here is that S, and that tells us that the lead iodide is the precipitate. Alright, here are the stages in making it. If you wanted to make the lead nitrate, you've done this before, so it's just a case of just thinking through. Usually we want the liquid, but this time we want the solid. So step one, carry out the reaction. Add the two ionic compounds together, the aqueous solutions, and you will form in the beaker, in here, the solid precipitate. Then what you need to do is filter that precipitate through a funnel. When you do that, the filtrate, the liquid, will pass through and the precipitate will be left behind in the filter paper. The last and final step is to dry the filter paper so that the precipitate, any liquid is left, evaporates away, and that leaves the dry precipitate. Right, the image on the screen is barium sulfate. This is something you've seen before. Barium sulfate is the solid that's formed when barium chloride is used to test for sulfate ions. It's what makes sulfate ions go white. It's a solid that X-rays don't pass through. It's really good for medical investigations. People used to be given barium meals, and what you can see here is I believe that this is a patient's stomach that this person's been given a barium meal, and when the sodium sulfate and the barium chloride that they've been given have mixed together, it's coated the lining of their stomach with this barium sulfate, allowing the radiographer to see the outline of the stomach. So this is almost identical content from C4. You've got barium sulfate, which is made by reacting barium chloride with something containing sulfate, in this case sodium sulfate. The metals swap places, and we also get this barium sulfate, which is the precipitate. You can tell it's the precipitate because in the bottom right hand corner we've got the little S for solid. You might be asked to draw what's called an ionic equation for the formation of barium sulfate. An ionic equation is just basically a situation where you're just showing the ions that are involved in the formation of that. So if you've got barium sulfate here, I'm going to rewrite this because of problems with super and subscript. Essentially, what happens there is the barium ion reacts with the sulfate ion to form barium sulfate. Really straightforward reaction. What we also have in there, things called spectator ions. They're the two. That's the other two ions, the sodium ion and the chloride ion. They're not actually involved in the formation of barium sulfate. They're described as spectator ions. So they're present, but they're really kind of not involved in the meat and drink of what we're concerned with. So when it's an ionic equation, it's just the two ions that we are concerned with that's making the product that we're bothered about. So another example here, we're talking about lead nitrate and sodium chloride reacting to form lead chloride. So all we're really bothered about is the stuff that comes together to form the lead chloride, the lead ions and the chloride ions. Lead ions there, Pb2+, and chloride ions, Cl-. So when we write the ionic equation, we only write out with the lead and the chlorine to form PbCl2, lead chloride. It has to be balanced, we need two of the chloride ions there. The other two ions that are involved, the sodium and the nitrate ions, they're described as spectator ions. They're not involved in the ionic equation that we're bothered about, but they are present. Here's one that you might like to try before I go through it, and then the steps are identified for you. So, lead nitrate and potassium bromide reacting together to form potassium nitrate and a precipitate of lead bromide. So firstly, what are the ions involved? So we've got lead nitrate. So we've got Pb2+, and we've got nitrate ions, which are NO3-. We've also got potassium bromide, so we've got K+ and Br-. Now we need to concern ourselves with which one we're writing our ionic equation about, and it's about this lead bromide. It's about the thing that's being formed that we're bothered about. So, the two ions that we care about, Pb2+ plus Br- form lead bromide. Now you should know that lead bromide is PbBr2, and it's PbBr2 because the charge is here, the 2+ from the lead and the negative there from the bromine need to be balanced. So in order to do that, we need two of these bromide ions, leaving us with PbBr2. We can input state symbols there. We've got aqueous, and solid. Potassium nitrate, why does that also form? It forms from the two other ions, the spectator ions. Spectator ions, as I already said, they're there, they're just not necessarily involved in what we're interested in. So, in summary, insoluble solids are prepared by filtering and drying a product after a precipitation reaction. State symbols S, A, Q, L and G are used in symbol equations. A, Q, and L are the ones that you're most likely to be confused because all aqueous solutions are within liquids, so that's why they're hard to identify. Spectator ions, they're present when a reaction is happening, not directly involved in the thing we're interested in. And in precipitation reactions, remember the precipitate is a solid, and we're basically swapping places in the metal ions in the ionic compound. Thank you very much for watching. I hope this series of revision videos has been useful to you. My name is Mr. Clee, and thank you again.